April 10th. Let's go ahead and get started. So today we're starting a boot camp. This is a boot camp all about statistics. In place of the normal practice sheets, you will just simply watch these lecture videos and take notes. And in place of the normal mastery quizzes, I've set up some Google surveys that you'll take just like mini quizzes. They're worth 2 points each in the grade book. And all of those will be due on April 27th at midnight, and I'll just grade them all at once. So you've only got the one attempt on them. That's the best way I could figure out to do this. And we'll figure it out as we go along, but this will be the video for boot camps 1 and 2. We're going to be looking at different ways to show data, starting with dot plots. So dot plots are a way to show frequency visually. What we do is we've gathered some data. This is data on hours spent on homework per week. And then we want to represent that data visually. So we draw on a number line that's going to capture all of our data. And then each dot represents a single individual and the number of hours they spent on their homework. If the dot is above the 4, that means there was an individual here that spent 4 hours last week on their homework. Now, in reality, they could have been anywhere in this interval from 3.5 to 4.5. All right, one thing about dot plots is that you always round to whatever degree of precision you're going to be putting your dots on. And the rounding is important because that gathers your data into these buckets. All right, and so we can see more clearly if we round to the nearest integer which number is the most frequent. And here we can see spending 1 hour on your homework per week is the most frequent in this dot plot. All right, so here we've got some data. This is data for the age at inauguration of various presidents. And we need to construct a dot plot because right now, looking at this, it's really hard to get any idea what the trend is, what's more common. The dot plot's going to make that go much quicker. Like if I asked, what's the minimum here? You'd have to search through the whole thing. But if you have a dot plot, you would just look at the furthest left dot. Okay, so let's talk about this word range. Range is the interval from the minimum to the maximum. Let's see if we can find the range of these presidents. We're going to need to know the minimum. We're going to need to know the maximum. All right, so looking through here, the lowest one I see is a 43. Let me scan one more time, looking for any numbers lower than 43. Nope, so that is my minimum, 43. And then for the maximum, I see Ronald Reagan at 69. I'm going to scan through looking for any numbers higher than 69. I don't see them. All right, so knowing the range is important because that's going to give you what part of the number line you need to draw. So number lines can be infinitely long. We just want the part of the number line where our data lives. So we looked for the minimum and the maximum. All right, so I'm going to put those dash marks on my number line, 43 to 69. And now I'm going to add in a couple for 50 and 60 to kind of help space out our data, and then I'll add in all the other ones. So 44, 45, 46, 47, 48, 49, 51, 52, 53, 54, 55, maybe label that one, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68. Yeah, we're in a little bit out of room, but I think that's okay there. All right, and now I'm going to go through my data, adding points on the line here for each number I see. So Rutherford B. Hayes, he was 54 at inauguration. So I go to the dash mark for 54 and I make a dot. And then I can cross that one out. Herbert Hoover, he was also 54. So I can't put that dot right on top of this dot, so I put it a little bit above. All right, and starts to make this bar that shows that this is a spot with more frequency of data. James Garfield at 49, he gets his own dot. Woodrow Wilson at 56. All right, and I think you get the point. I'll pause the video here and fill in the rest of my dots. And there you have it, our dot plot for this collection of presidents and their age at inauguration. Now that we have the dot plot, it's really easy to see what the range is. You can quickly see the minimum and the maximum and what the most frequent ages were. Looks like it was 56 with 3 different presidents and 54 and 51 with 2 different presidents. All right, let's try another one. This is basketball tournament champions. So what we have here is the number of times each of these schools has won the championship. Oh, this is reminding me, we need to label this axis here age and give it a unit, years. Okay, so what's going to be the axis for this one? This one would be wins. And that one doesn't really need a unit. We could just say number. So it's clear that we're not doing like multiples of 10 or something. All right, minimum and maximum, I can see them pretty easily. The maximum is 11, the minimum is 1. So I need a number line that goes from 1 to 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, and then each number I see here gets to become its own dot. So the 11 becomes this dot right here. The 8 becomes this dot, representing Kentucky. Maryland's 1, 1. Syracuse is 1, 1. Cincinnati 2. Louisville 3. Wyoming another, just 1. California 1. I'm up to here. 1, 2, 1, 1, 1, 2, 5. All right, so we can see the most frequent number is for a school to just have one title. And then there's this data point way over here. We could call this an outlier. UCLA is a real outlier because its data point isn't anywhere close to these other data points. Kentucky is also a bit of an outlier, but it's at least a little bit closer. UCLA with 11 wins is just way out in front here. All right, and one more. Here's one on sales tax. You could pause it here. I'm going to pause it here. Try to construct this one on your own, and we'll see how they compare. All right, and here we go. Did you pick up that the unit was percent for sales tax? Does your graph look about right? Well, hopefully it does. Good work. It's time to move on to our next way to represent data, which are stem and leaf plots. So this is another way to show frequency that rounds the data a little bit less. So in order to be on the dot plot, you have to round to match the scale on the bottom, but that could lose a little bit of precision. Like with our homework example, if you were studying 3 hours and 27 minutes, that whole 27 minutes will be lost when it's represented as just a single dot on the 3 on the number line. This just keeps an extra significant digit. And so what it's like doing a dot plot on its side, but instead of putting a dot, you put just the next digit in the number, and then you put a key at the bottom for how to interpret this. So here we've got a stem and leaf plot showing race running times in seconds. Each one of these leaves is an individual getting a time recorded on this race. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23 contestants. So there's 23 data points. All right, and then how you decode each of these data points is you take the number on the leaf side and you add it to the number on the stem side. Well, you append it to the number on the stem side. So if I see a 2 over here, across from the 12, it becomes a 122. But then we see in the key that we're supposed to put a decimal point right there, so it's really just 12.2. So let's try to decode another one. This 8 here, it's across from the 16, so that becomes a 16.8. All right, let's see if we can go the other direction. Here we've got a bunch of data. We want to construct a stem and leaf plot for this data set. So I need to pick some reasonable values for the stem, which means I got to look through the data a little bit. All right, so I see my minimum is maybe this 52. My maximum, maybe, well, this one, 84.2. That's pretty high up there. So looking at that, a good number to pick for the stem would be the digit in the tens place. So I'm just going to take the very first digit, 5, 6, 7, 8, as my stem. All right. You can't take less than just the first digit, and taking any more, we would have way too many stems, not enough leaves. We want fewer stems, something around like between 4 to 10 is optimal, and then mostly groups of leaves. All right. So one thing about putting these data points into the stem and leaf plot is that you have to round them to whatever digit the leaf is. So here the leaf is the ones digit. So for Antigua and Barbuda, this 75.8 has to get rounded to 76. And then I can put a 6 over here across from the 7. All right, for the United States, this one gets rounded to an 80. So it actually gets a data point right here for that 0 across from the 8. South Korea, 81, so we're going to put a 1 there. Latvia, that'll round to a 75, so we go 7, put the 5 over here. Kuwait, 78. Nepal, 69. Liberia, 59. We'll make that a 75. 84. 56, 69, 61, 63, and then up to 73 and 52. So another thing about stem and leaf plots is that after we've constructed it for the first time, you want to do it over, but put all the leaves in order from least to smallest, or from least to greatest. All right, so stem, leaf. I'll pause the video again to organize these. All right, here is our stem and leaf plot organized, and you can see it kind of looks like a dot plot on its side. We can see more frequency here in the 70s, less frequency in the 50s and 80s. It's very easy to see what our minimum and our maximum are. We just look at the very first number in the first column and the very last number in the last column. So we can see we go from 52 to 84. And then it's important to put a little key at the bottom here. So key 5, line 2, that line represents the break in the middle of the table, equals 52. And we'll give it a unit, years. Okay. Here's some more data. It's on the height of some very tall mountains. But there's a little bit of an issue, is that all of these heights all start with a 2. So if we made a stem and leaf plot with this, and we just put a 2 on the side of the stem, then every single leaf would be in that same column. We wouldn't be able to really get a great grasp of our data. So what we do is we move one more digit in, and we do that interval. So let's see, our shortest is maybe a 23.8, 23.6. Yeah, these ones here are the shortest, and they all start with a 23. Then this goes up to 24, 25, 26. Are there any 26ers? There are a couple 26ers. All right, so we'll start with the first 2 digits so that we spread out our data a little bit more, but not too much. All right, and then we round to that 3rd digit. So 23891 becomes 239. So 23900, and then a 9 comes over here. All right, next one we put a 2, then a 0. 551 becomes 25.6. So we're gonna put a 6 here for the 4th mountain. Another 25.7 when we round that one. 24.6. 26.1. No, 26.6 for this data point here. 25.4. 25.6. 23.6. 26. This 3 gets rounded up to a 4, so 26.4. All right, I'll finish up the last couple here and then reorganize this. All right, and there we go. Here it is organized. We can clearly see where the majority of the data is. We can see our range. And it keeps a lot of information about the accuracy of these numbers, the precision of these numbers, because you've got 3 digits here for each mountain instead of just having to round it to put it on a dot plot. And this wouldn't work great for a dot plot anyway, because you wouldn't really have any columns of dots, because that would require 2 mountains to be the exact same height. All right. Here's one more. You can pause it here, try to make your own stem and leaf plot. I'll pause mine, make mine, and then show you what I came up with. All right, and here's the stem and leaf plot for this one. Let's remember to put a key for this one. So the key 3, table line 9 equals 39 years. And I'm remembering we never added a key to this one. So for our key, we'll just pick that first data point. There you go, got a right key. 23 line 6 equals 23,600 feet above sea level for these mountains. All right, call that good for this video, and good luck on the mastery quizzes. Have a good rest of your day.